Welcome to myprojectbazaar.com. Let us start with our title, containing Byzantine failures with control zones. So this topic deals with the node configuration and message sending across the network. So here we go for the introduction of our topic. Generally, some nodes probably in network fail during the broadcast messages in network. So this option means the node in network may be failed due to the any improper setting in that node which carries the message to other node. So improve this failure option. Here we are going to propose a new protocol for the reliable broadcast message in a network. So here the Byzantine model is judged using the common failure model. So here we are going to take the common failure model called Byzantine failure model, and here we are going to propose the solution for this Byzantine failure model. So it consists of failures in a random behavior manner. So any node in network may be fail, and the failed node does not send a message to any other nodes in the network. In this way, the failure in network may be occur due to the Byzantine nodes. So we have to identify this Byzantine nodes and maybe process, and this processing is done in an effective manner based on the above protocol generation. So here we mainly focus on the decentralized network, and our broadcast is introduced to control this failure of Byzantine nodes. So here we are going to propose a new protocol called as a broadcast protocol, which is going to reduce the Byzantine failure into the large extent. So to reduce this Byzantine failure for a large extent, we are going for a concept called control zones. So the nodes which are placed in the control zones always communicate reliably in the network. So in this option we are reducing the Byzantine failure to the large extent. So from the above protocol we are here improving the probability of protocol to the large extent. So our proposed system really improves the efficiency of message sent in a network to the large extent. So here we go for the proposed system of our concept. In this proposed system we introduce the broadcast protocol to control the false node in a network. So our proposed protocol mainly focus on interconnected subsets called control zones. So nodes in this control zones are interconnected and always communicate reliably. This is done because of filtering of false messages in a network. So this is identified based on the authentication service provided for the each node. In this way we identify the Byzantine node in an effective manner. Our main objective is to improve the communication and reliable service through the network of Byzantine node, and this Byzantine node should be filtered from the other node and kept separately from the network. So here we go for the flow diagram of our process. First, the broadcast message to be sent is chosen. Next, the message enters the network. And the message is passed to the all nodes in the network. After passing the messages, it is verified whether the node is neighbor node or non-neighbor node. If the node is neighbor node, means our new proposed broadcast protocol is applied. So if the node type is not neighbor, means it is sent to the another nodes in the network. So finally, after applying our protocol successfully to all the nodes in network, the message will be reached to all the nodes in our network. So this is the concept of our flow diagram of our process. So let us start the demo for our process. Simply open the NetBean and choose the home page option, which is the first page of our process, and choose the right click and select run file option. So after selecting the run file option, the home page of our process start to run, and minimize this home page and select the node config.java and choose the run file option. So in this page only we are going to declare the nodes which is under the control zone. So the nodes under the control zone is declared first. For example, gives the number as 2 and create 2 nodes. So the nodes are created as number 1 and node number 2. So this is the nodes created which is placed under the control zone. After creating the node, select the property of nodes. So simply first choose the node 1 and give any name for node 1. Choose the name, choose the IP address and set the password for the first node, and simply click the assign option. So the above properties are declared and the above property is successfully assigned for the node 1. So in the above manner, simply click the node 2 and assign the properties for the node 2. So simply choose the name and simply choose the IP address and simply choose the password for the next node and simply click the assign option. So the properties for the node 2 is assigned successfully. So here we have created the node successfully, and here we have provided the properties for node successfully, and based on this properties only the authentication will be generated on the previous and the next upcoming process, etc. So we have assigned the properties to generated node successfully. So simply click the node entry option. So in this node entry option only, the node verification will be done whether the node is placed under the control zone or whether the node is out of the control zone. So simply click the list of deployed nodes. This shows the number of configured nodes for our process. So we have only configured 2 nodes, that's why it shows as a node number 1 and node number 2. Simply enter the IP address for node 1 and password for node 1. If you click the validate entry means, so simply choose the node 1 and click the enter the IP address and enter the password for node 1. If you enter the wrong password means, so the message will be displayed as the unauthorized Byzantine node is recognized. So simply click the OK option and enter the correct password and IP address for the node. So if you click the validate entry option means the password and the username and the IP address matches with the node which we have recognized earlier, means the node will be recognized, message shown. So simply click this OK button and it goes for the next form called node 1 page. So in this node 1 page only the sender and the receiver node will be chosen. So here node 1 is the sender and node 2 is the receiver. They both are going to communicate in a simultaneous manner, and the message are going to be transferred in a network based on these 2 nodes only. So simply click the get details option. Here you will get the details of node 1 and its IP address. Here simply choose the receiver node option. So there is no other option, only 2 will be the receiver. So after choosing the 2, simply click any text file. So it may be any file to be transferred in a network as a broadcast message. So simply choose any file. It may be any text file. So simply choose any files, such as it may be in any directory or any process of your document. So simply choose the text file option. So click open option. So if you choose the option means the information about the file will be displayed and the file size and the text file name will be shown here. So after choosing the file to be transferred as a message in network, simply click the update option. So this update option updates the text file chosen as a message to be sent in a network. Simply click the OK button, and here we are going to generate the random nouns option. So this random nouns only going to generate or going to verify the nodes placed in the network. So simply here enter the node number as 5 and generate the random placement. So here we have placed 5 nodes, 5 zones under the control zone. So the random placement for the control zones are displayed here. So here simply choose the sender node. The sender node is no other choice, it is node 1 only. So if you want to know the nodes placed under the control zones means, click this button and it shows the number of nodes placed under the control zone. So there are totally 5 number of nodes which are placed under the control zone, and simply click the, after generating these properties, simply click the plain IV key. So IV key is generated here and it is displayed. So here we are using some of the keys which is used in the encryption and decryption option, which is used in the message transfer. So generate the secret key will be also generated. So after generating this, simply click the plain text option. So this plain text option shows the content of text file which he have chosen as a message to be sent across the network. So after choosing the content, simply click the block typer option. It generates the encrypted content of the text file which we have chosen. So the file chosen is successfully encrypted, and the encrypted file only sent as the broadcast message across the network. So after clicking the block typer, click the message authentication option. So here only we are going to provide the message authentication for the receiver. So after providing this message authentication only, the receiver can able to successfully receive the message from the sender. So here we are going to generate the tag. Here we are going to generate the tag formula. So this tag formula is used as the main option for our process. So simply here generate the tag formula. So this tag formula is used to generate the authentication tag which is generated for the user. So tag formula is successfully generated, and here simply click the authentication tag option. After authentication tag option is chosen, simply click the get R and N value. So this is the random node and the random placement of the node which is generated earlier. So after generating this value, so simply click the message option. So in here in this text box, the message which we have chosen, that is the text file which we have chosen, is generated. So this is the message which we are going to send across the network, and for this message the authentication key will be generated after clicking the binary R and binary M option. So these are the converted contents of the file in a binary manner. So this is only sent across the network, and the original file will not be sent across the network. After generating the binary messages, simply click the authentication tag option. So this authentication tag to be verified at the receiving end for the effective decryption process. So simply click the send to receiver option. So here the authentication tag is generated. Simply click and the authentication tag can be viewed. Here the unreadable text, that is the encrypted content of the original text file, appears. So after appearing these contents, simply click the port number. So port number is declared for receiving the authentication. Here we are going to send the tag for the receiver. So after clicking the send tag option, simply the message will be displayed, authentication tag is sent to receive, and click OK in this option. So after clicking the OK, minimize these files and choose any option. So after clicking or after sending the tag, so simply click the node login option. So run file. So wait for a while till the file runs. So here the list of nodes will be displayed, and the receiver node is node 2. So here we are going to enter the node 2 option only. So simply enter the IP address and password for node 2. The entry will be validated, so the node will be recognized. So after pressing the get details, here you should enter the port number which is sent by the receiver. So after entering the port number, here the tag will be received. So the message will be displayed, received from the tag from the node. So successfully after receiving OK button, the tag will be displayed here. So here we have sent the tag successfully from user to receiver. So simply minimize this screen, and after minimizing this screen, simply open our process, and here we are going to generate, or here we are going to send the block cipher message for the receiver. So simply change the port number, and here you should choose as a send text option. So after choosing the send text option, the message will be displayed, and simply click OK in this option. So first of all, we have sent the authentication tag to the receiver, and after sending the authentication tag, here we are sending the text file to the receiver. So simply click the OK button and go for the form which we have logged in, and simply changed port number in the receiver side as same port number in the sender side, and here receive the ciphertext option. So here we have successfully received the ciphertext for the original text which we have processed. So simply click the plain text and authentication. Here we are going to receive the contents based on the ciphertext. So this is the ciphertext of our original text which is received. So R is received here. R means the binary values which is used in the placement. So after receiving this content, here we are going for the content conversion. Though content conversion means the content is converted from the original text to ciphertext to the original text. So after clicking the content conversion button, you will be displaying with the message box decrypted successfully, and click the OK button. So after clicking the OK button, if you click the original message, means the original message will be displayed here. So after clicking these options, you can get the plain text here, and you can get the random message here. After generating this random message, you can get the authentication tag, you can get the binary R and binary M values are generated here successfully. So after this, generate option is generated and validate option is chosen, and the data authentication is validated here successfully. So after these comparisons have been done, we have chosen with the data privacy ratio. It is generated for the privacy transaction and number of messages sent across the network. So this is one of the option, and the another node authenticity is compared here. The node authenticity means the number of messages passed and the secured authentication across the node in network is recognized. So successfully we have achieved the task. We have applied our broadcast protocol in an effective manner between the sender and receiver in a network for the effective authentication of nodes and effective recognition of nodes in the network. So thus we have achieved the main aim of our process as controlling the Byzantine failure using the set of nodes called control zones, and these control nodes are recognized based on the username and password in an initial level. By applying the protocol, we have successfully improved the efficiency on sending messages. Thank you.